This question reads, a rectangular plot of farmland will be bound on one side by a river and on the other three sides by a single-stranded electric fence. With 2,100 meters of wire at your disposal, what is the largest area you can enclose, and what are its dimensions? So let's draw a picture. We have a rectangular plot of farmland. All right, so something like that. And then one of the sides is bound by a river. So we've got a river running here. Okay, so only the sides that are in black will actually be pieces of the fence. So the longer side we normally call the length, and the shorter side we normally call the width. Okay, so what we know is that we have 2,100 meters of wire. So the 2,100 needs to equal the side called the length plus each of the sides called the width. And so we get this equation that 2,100 meters of wire needs to equal length plus 2 widths, or 2W. Okay? Now what we're trying to do is get the largest area possible. We know that the area of a rectangle is length times width. To come up with a maximum, though, we can't be working with two variables on the right-hand side. So what we do is we use this equation that we wrote here to come up with a substitution to make it so that area equals only one variable. So what we can do is, from this equation, subtract 2W on both sides, canceling on the right, and so we have 2,100 minus 2W equals length. And so we can take this equivalent statement for length and substitute it in to our area equation. And when we do that, we now have an equation for area that only has one variable, the width variable. Now that we've done that, we can find a derivative and go through the process of finding a maximum. So before a derivative, let's go ahead and use the distributive property. Multiply through by W. Okay, to find a maximum, I find the derivative, which is 2,100 minus, multiply this 2 in front times 2, we get 4W, decrease the exponent by 1. Okay, and now we take this and we set it equal to 0, and we solve for W. So I can add 4W to the right and divide both sides by 4. And so we get that W equals 2,100 divided by 4, which is 525 meters. Okay, so that's half of my answer. The other half of the answer is to figure out the length. Okay, the length is found by taking 2,100, subtracting 2 times W. We now know that W is 525. And so our answer then, 2,100 minus 2 times 525, and we get 1,050 meters. Okay, so there's my length. And then the last question asks about what is the maximum area that you can enclose. Okay, well, to do that, we just find the area of this rectangle. So we have area equals length times width, so 1050 times 525. And you can do that on your calculator, and we see that that is 551,250. And area is in units squared, so meters squared. Okay, and so there's our three answers that finish this problem.